So, first we have to state two errors that Angharad has made on her graph. And the first one is relatively easy to spot because looking at the data you can see there's nothing that just stays the same all the way across. So this line here, which represents the whole of Wales, is wrong. It's an odd error. I can't imagine how Angharad managed to do that. It could be that Angharad is plotting for the Wales line against the year, and we can't see that because the scale on the y-axis doesn't allow us to see the difference between 2008 and 2017, so that's a possibility. Who knows? The other error is that the results for Gwent and North Wales are mixed up. So if we look at the results for Gwent, then we can see that starts with 1060, which is here, and it ends with 237, which is here, and we can see that the dotted line that represents that is actually says North Wales, and it should say Gwent. If we look at the results for North Wales, we've got 1956 initially, which is here, and it ends with 341, which is above the other one, and that's the solid line that says Gwent. So these two should be the other way round. Then we have to think about what other information Angharad needs in order to conclude that South Wales is the most dangerous region of Wales in which to drive. So it's worth thinking about why she thinks that, and she thinks that presumably because this part of the graph here is higher than all the others. What she hasn't thought about in drawing this conclusion is that the different regions may well have different populations. They will have different numbers of roads, and these are the two examples of valid statements given in the mark scheme. I think probably for me an interesting figure would be how many miles travelled per person for each region. That might help to allow us to draw a sensible conclusion. But from this graph, the only conclusion you can draw is that South Wales has had more accidents. So for part B, it's asking us to calculate estimates for the mean and standard deviation of the number of accidents per region. Now, this can all be done on the Classwiz, which I'll show you after we've gone through the whole question. But even if you use the Classwiz, writing down what you've done is a good idea. And in fact, there is a mark for writing the formula, either with letters or with the numbers put in. So this tells you that the word calculate doesn't mean you can just enter it into your calculator and write the answers down. You've got to show that you understand to some extent at least what's going on. So we'll do it an old-fashioned way to start with, which will mean that you write down everything that's needed to make sure you pick up the marks, and also that you understand the mathematics. But we will look at the Classwiz later, as I said, if only because that's a good idea to stick the numbers in there in order to check your answers. So for the mean, we have x bar is what we use for the mean, and that is going to be the sum of the frequencies times the midpoints. So because there are 6 here and the midpoint is 25, then an estimate for how many accidents altogether are contributed by that part of the table we get by multiplying them together, which is why we get sum of fx. So that's going to tell us the estimate for the number of accidents, and then if we want a mean, then we have to divide by the total frequency, so the sum of the frequency column. And I'm not going to spend time doing that calculation in this video, but it comes to 2058 divided by 22, and that is 93.5454, etc. And because the midpoint is only one decimal place, then we can't reasonably give this mean more than one decimal place. I always like to state what I've done so the examiner knows what I'm doing. Now, for the standard deviation, we have that sigma squared is equal to the sum of the squared values divided by how many values there are, take away the estimate for the mean squared. And again, I'll say something about that in a moment. Now, they have very kindly given us this sum of fx squared. It's not kind, really. It would be a real waste of your time in an exam to be doing such a boring and tedious and simple calculation. Now, at this point, it's not going to make a great deal of difference, but it's good practice to actually use the exact value. Even though it's only an estimate, it's still an exact value from the data we've got, rather than using the 93.5 at this point. It may just make a little difference. Probably not in this case, but it could in another situation. And anyway, we bung that in our calculator, unless you can do it in your head, and then we square root, let's put sigma squared, which gives us 4,435.116 ... and so we then square root to get 65.0655 ... and again I shall just round that off to one decimal place. Now, this formula here, which you need to know, if you're struggling to remember it, there is a sort of clue towards it in the formula book, which is this line here that just appeared on the screen magically a minute ago. And this actually refers to distributions. So the P there is talking about the probability of each of the elements. So this says the sum of each value squared times its probability, and then take away the mean squared, which looks pretty similar to what we've got. But if we think about the probability and think that that's essentially the frequency of each element divided by the total frequency, then what this formula becomes is sum of the xi squared times its frequency over the sum of the frequencies. And then the minus mu squared, we will call it x bar squared. The reason for using x bar is that mu is the actual mean, so when you're dealing with a distribution, because it's a theoretical construct, then it has an actual mean. And if you were dealing with actual numbers rather than estimated by using midpoints of intervals, then we could use mu, but in this situation, because we're estimating, we are using x bar. And that then becomes sum of fx squared over sum of f, take away x bar squared. So that's just a way that you might be able to help yourself to remember the formula if you're struggling to, by referring to the formula booklet, and it might be worth just scribbling this little derivation out for yourself a couple of times to help you remember it. Now, I said I was going to put how to do this question using the Classwiz at the end of the video, but I've changed my mind mid-video, and you can use this to do the question or to check, or both I suppose in a certain way. Anyway, blah blah blah. The point is that we will get to this screen by turning on and pressing menu 6 and then 1. So menu and 6 and then 1, and that gives you this table here, and you can then put the values in, which you can see I've done. To move down the page you can use your cursor. Once you've entered all your data, you then press OPTN, short for option, and 3, and then this will come up here. And in here you can see some of the numbers you need. So, for example, we have the 2058 here. We have the final value for the standard deviation here. So that's that. We also have the sum of the x squareds, sum of the fx squared I should say, which is here. And we also get our mean. I don't know why I'm doing these in a funny order, but there we are. It's probably good for your brain to do it in a funny order. It'll help you remember it. You never know. Anyway, there are some others on the next screen, which I'll show you in a sec, but the fact that this gives you the sum of fx squared and they've given you the sum of fx squared in the question is more reason to be doing more of a calculation as we did earlier. And just for completeness, I wanted to show you that we have the frequency here on this page, just there. We get to this by going down from the last page on the cursor. So there we are, Classwiz, brilliant. So we now come to more errors by Angharad, who is getting a bit of a hammering in this question. So what has she got wrong? Well, we have frequency here, and it is not the frequency. We know from our table above that the frequencies go up to 9, and this doesn't. So this should say frequency density. Angharad says more vehicles respond in a time between 10 and 11 minutes than any other 1 minute interval. Comment on her statement. Well, that may be true, but it may well not be true. For example, if we look at the column between 8 and 10, so this one here, that has a width of 2 and a height of 2.5, so it represents 5, because the area in a histogram represents the number. So all of those 5 could have happened, for all we know, between 9 and 10 minutes, or between 8 and 9 minutes, in fact. So we just don't know. The skewness, well, if we sort of give it a nice rough over curve, we can see that the tail is off to the right there, and so we can say that it is positively skewed. And that, you'll be pleased to know, is that.